Okay, we're doing derivative of an inverse function. Please make sure you watch the videos on AP Classroom. This is a very quick topic, but because it's very quick, it's hard sometimes to really grasp it and to recall it. So we did inverse functions in Algebra 2, if you took Algebra 3, math analysis. An inverse is special because in an inverse, you switch the x's and y's, which means your domain and range are switched. If you graph the function, it's a reflection over the line y equals x, and the notation that is generally used is the inverse of f of x is notated as f raised to the -1 of x. It doesn't mean that you flip the function. This notation here specifically means inverse. And it gets really cumbersome when you're talking about derivatives. The other thing important about inverse derivative of inverse functions is that the composition f of g of x equals x and g of f of x equals x. And then a slope of tangent lines of inverse functions. This looks absolutely horrific to look at in math language. So let me go ahead and show you some examples. So when I do these problems, I start out by writing things in a different way. It makes it easier for me to look at. So if I know f of 3 equals 8, I'm going to write this is the point 3, 8. And I know my slope is 5 because this is the derivative. So I want to find the inverse derivative of 8. So I know if 3, 8 is the point, then the inverse has the point 8, 3. And believe it or not, from this definition, the slope of the inverse is going to be the reciprocal of the slope of the function. So the slope of the inverse is going to be 1 over 5. Okay, so not complicated. It's just easy to make mistakes in a lot of little areas. So for the AP test, you could see it in a lot of different ways. This was just written as a point. I could also give it in table value. So I'm still going to analyze this all the same way. So g is the inverse of f, and we want to find g prime of 6. So for the function g, I know I'm going to have the point something and 6. Oh, sorry, no, backwards. 6 and then something. And I don't know what that is. So I come over this table if I know that f then is going to be point something and 6. I come over to the table, and when f of x equals 6, so y equals 6, I know I have the point 2. So I know for the function f, I have the point 2, 6. Which means for the inverse, I have the point 6, 2. So then I look here. I don't have any information for the function g. So I'm going to have to get my information from the function f. So my slope, f prime of 2, is going to be 1/3. If my slope for the function is 1/3, then my slope for the inverse is a reciprocal of 1/3, which is 3. So you don't even need this information down here, and that's typically what happens. It's not that they're trying to trick you, it's just trying to see if you truly understand what you're doing. Okay, this next one I'm given this function f of x, and I'm given the inverse g prime of 0. This looks 0 looks funny. Your formulas or your note sheet, I've corrected it. I just didn't correct it on this yet. So that means I have for the function g, so for g I've got the point 0 something. So for f I have the point something 0. Well, I can find that point, and this one is, there's not really an algebra technique. I'm going to say, well, 0 equals x cubed plus x minus 2. And the rationale behind this, if 2 is equal to x cubed plus x, I can't factor this and find it. You know, this I'd have to use rational root theorem, but it's actually easier than that. To get it to, the only way I can get it to is if I add 1 and 1. So I know x has got to equal 1. So now I know I have the point 1, 0. The function g has got the point 0, 1. I can find the derivative of f of x, 3x squared plus 1. So then I'm going to use this 1. So f prime of 1 equals 3 times 1 squared plus 1 equals 4. So since g is the inverse, g prime of 0 is equal to 1/4. A few more examples. And there just really isn't a lot. There's nothing in your textbook to practice this. So I've got, we'll use Delta Math, and then I'll try to find some more material as well. Okay, this problem is a common problem in AP, talking about vertical tangents. Well, if you have a function, in this case it's not a function, it's an ellipse. And this ellipse, I can show you on Desmos, but I'm going to show you, it looks like this. And so I'm going to have vertical tangent lines here and here. So first thing I need to do is I'm going to go ahead and find the derivative of this. So I know that, and I'm going to have to use implicit differentiation. 8x plus 18y dy dx equals 0. We solve this for dy dx. So dy dx is equal to negative 8x over 18y. Oops, forgot to write the y there. So this is going to be negative 4x over 9y. And you don't have to simplify. So what happens, the vertical tangent line occurs when the denominator is equal to 0. So I would usually just set the denominator equal to 0. I've also seen it done where, well, let's flip dx dy. And I've got 9y, negative 9y over 4x. So it's the same thing. So this has got to equal 0. Dx has got to equal 0 when y equals 0. So now that I know y equals 0, I come back to my equation here, 4x squared plus 9y squared. Well, y is 0, so I'm going to put a 0 there. And I'm going to solve for x. So I get x is equal to plus or minus 3. So the two places where there's a vertical tangent line is at the point 3, 0, which would be this one, and negative 3, 0, which would be this one. Here's another way that you could see this problem. So I'm given f of x equals 1 over x, and I want to find h prime of 3. So once again, for the inverse, I've got the 3, and I don't know what the next point is. So for f, this is for h. So f, I don't know what the x is, but I know the y is 3. So I could come here, well, if I've got f of x equals 1 over x, I have 3 equals 1 over x. Cross multiply, I get x equals 1/3. Then I can find the derivative of x. So the derivative of 1 over x, remember this is x to the negative 1, negative 1, x to the negative 2, f prime of 1/3 is going to equal negative 1 over 1/3 squared, negative 1 over 1/9, negative 1 times 9 over 1. So it equals negative 9. Since I have, this is the derivative for the function, the inverse derivative, so h prime of 3 is going to be the reciprocal. And our last problem, once again, it goes back to table format. And this table was used in a book I got it from that had a lot more questions. So this is a lot of information. You don't need it all at all. So I want to find I'm saying that the function s is the inverse of f. So if for my function s, I'm going to have the point 3 and something. So that means for my function f, I'm going to have the point something and then 3. So I come to my table when y equals 3. Okay, here's y equals 3. This is the point I want. So I know that the function f has the point 1, 3. So that means my function s has the point 3, 1. I don't have any information here about s, but I do have it about f. So I know the derivative of 1 is right here. Since the derivative is 2, my inverse is going to be the reciprocal of 2, which is 1/2. Very odd. We don't spend a lot of time on this. There's not a lot of work to practice on it. I've taught it in different sections, usually not this early, but before the AP test, we'll review these.